So we're going to look at how we can determine what a basis is or how to find a basis. And one of the techniques we've seen already, and that's what we call, or I'll call, method 1 out of 2. And we've actually done this already. So this is where we would take a particular set of vectors. So we'll take a subset of vectors V. That's going to be V1 up to Vm. And that's going to be a set of vectors that spans a subset W. We would then just kind of throw all of those vectors into a matrix, put it into row reduced echelon form. Of course, that only works on the row space, as we saw. So we had to transpose the matrix, row ref it, and then transpose it back. And that allowed us to eliminate the linearly dependent vectors in V. There, we could use the non-zero columns to form a basis for W. And that was essentially what we did in previous lessons. So this is an efficient, straightforward method, but the downside is the basis vectors are not the same. So we no longer in the same coordinate system that we were using with the initial vectors. So if we wish to remain in the same coordinate system and have the same basis vectors without the linearly dependent ones, we need some other method to do that. And I'll dub this method 2. So here what we do is solve the vector equation x1 v1 plus dot 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 plus xm vm equals 0, so the homogeneous system, if the only solution is the trivial one. You guys should know the answer to this. Then the set is linearly independent. And therefore, the set is already a basis for W. If there is no trivial solution, in other words, there are free variables, for each of the x's that are associated with a free variable, we can delete the vector from the original set. This is maybe a little bit hard to articulate, but essentially we look for those places that have leading ones, which are sometimes referred to as the pivots, and then we grab those vectors for our basis. If a particular column does not have a leading one, then it would not count as part of our basis out of the original vector set. And we'll work through an example of this so we can see this happening too. So one more time, if there are no trivial solutions, and that means there are free variables. So for each xj that is free. We delete the associated vector that was in the original set V from our larger set V. The remaining vectors then are the basis. So this is essentially our method 2. When it's written out like this, it looks a little bit worse than it really is. In reality, it's a pretty straightforward process.